Alright, happy Wednesday everybody. Our lesson for today is going to be over balancing chemical reactions. I do have some PowerPoint slides that go over this, but I think it might be easier if I can do it on the whiteboard so that you can see my thought process and how I work through these problems. So feel free to look at those PowerPoint slides. I think this will be more helpful too. So this is all showing the same reaction here on the board. I've got aluminum in its elemental form. It's reacting with zinc chloride to make aluminum chloride and zinc in its elemental form. The difference is that this top reaction that's all in black, it doesn't have any coefficients. We would call this an unbalanced reaction. It's unbalanced. And then this one that I made all colorful, it does have coefficients in it. This is a balanced reaction. And then these pictures just represent the different elements. It's color-coded there. So what's the difference between a balanced reaction and an unbalanced reaction? The difference is that one of them follows the law of conservation of mass and one of them doesn't. So we got to think, what is the law of conservation of mass? This is stuff that we've been doing since the beginning. The law of conservation of mass, it says that matter can never be created or destroyed. You can never create matter. You can never destroy matter. You can only change its composition. You can change the way it's put together. You can take it apart and put it back together in a new way, like Legos. But we can't end up with more of something or less of something. It'll always be an equal amount of matter. So let's look at this top reaction in black and see why it's really a bad reaction. It's unbalanced the way it's written. Up top here, I have one atom of aluminum as a reactant. I only started with one atom of aluminum. But on the product side, I've still got one atom of aluminum. That was a bad example to start with. Let's look at chlorine instead. On the reactant side, I have two atoms of chlorine. But on the product side, I've got three atoms of chlorine. So according to this top reaction, I made another atom of chlorine. But I can't make matter. I can't destroy matter either. I can only change the way that it's bonded. So this top reaction is unbalanced. It breaks the law of conservation of mass. But then this second reaction is balanced. It follows the law. If I've got 3 molecules of zinc chloride. Each molecule has 2 atoms of chlorine. So 3 times 2, that gives me 6 chlorines total. I can also count these green dots here, 6 chlorines. And then on the product side, I've still got 6 chlorines. 2 times 3 is 6, and I can count that I've got 6. 2 aluminums on each side, 3 zincs on each side. This is how we want our reactions to look. We want them to be balanced so that they can follow the law of conservation of mass. So in our next step, we need to figure out, how do we go from something like this that's unbalanced to something that is balanced? How can we figure out which coefficients to put on the blanks? That's what I'm going to show you next. Alright, so let's start it off with an easy example. Right now, this reaction is unbalanced. If I'm looking at this, I've got elemental sodium. It's reacting with magnesium bromide to make sodium bromide and elemental magnesium. But I've got a problem. Like I said, this is unbalanced. On the reactant side, I've got 2 bromine atoms. But on the product side, I've only got 1 bromine atom. So how can I fix this? How can I balance this reaction? I've got to use coefficients. I'm going to put coefficients where these blank spaces are to make this reaction balanced. You will never add coefficients into the middle of a compound. That compound will keep this composition. By that I mean, for every 1 magnesium, there need to be 2 bromine atoms. And we learned that when we were doing ions. It's gotta be in this ratio. 2 bromines for every 1 magnesium. That's to keep the charges balanced. So don't go putting coefficients into the middle of a compound. It's always got to go in front. I'll usually leave blank spaces for you. So, on the reactant side, I've got 2 bromines. On the product side, I've only got 1. So on this blank right here, I'm going to put a coefficient of 2. This way, I've got 2 bromines on the reactant side and 2 bromines on the product side. 2 times 1 is 2. But now I made something else unbalanced. Now I've got 2 sodiums on the product side and only 1 sodium on the reactant side. I need to make it match, so I'll put a coefficient of 2 here as well. Now I've got 2 sodiums on both sides, 2 bromines on both sides, and only 1 magnesium on both sides. This is a balanced reaction. 2, 1, 2, 1. You don't have to put the 1s here. If it's a coefficient of 1, you can leave it as a blank, and it's understood that there's only 1. But this is a case where if you feel more comfortable showing me that there's only 1, that's fine. You can go ahead and put a 1 there. Just make sure that it's really clear that it's a coefficient, so it's the same height as your capital letters, and make it really clear that it's a 1. I would prefer something like this to just a line. This is going to be a little bit unclear for me whether that's supposed to be a lowercase l or a 1. But then also remember, you really don't have to put that coefficient of 1 there. It's understood that I only have 1 if there's not another coefficient there. So that's kind of the easy way to do it. Let's see how we would approach maybe a harder problem to balance. We'll do that next. Alright, so here's the type of reaction that would be a little bit harder to balance. Anytime that you have a combustion reaction, these are some of the hardest reactions to balance. How do I know it's combustion? It's reacting with oxygen gas, and it's making carbon dioxide and water. So that's a really, really good indicator that this is a combustion reaction. And it's not balanced the way it's written right now. I've got 3 carbons on the reactant side, only 1 carbon on the product side. 8 versus 2, 2 versus 1, 2, 3 oxygens. It's all unbalanced. So I've kind of got to start from scratch here, try to figure out what coefficients can I use to balance this reaction. I'm going to show you a little trick that Mrs. Fack taught me. Shout out to Donna Fack. She calls this the rep table. The rep table, R-E-P. So what she does, you make yourself a little table that looks like this, rep. This stands for reactants, elements, and products. Reactants, elements, and products. So start with the elements, that's the easiest part. What elements are taking place in this reaction? Well, I got carbon, and hydrogen, and also oxygen. So these are the 3 elements that are taking place in the reaction. Now I need to count up how many atoms do I have of each element for the reactant side and for the product side. I'm going to switch colors here. So, on my reactant side, I've got 3 carbons. I'll put a 3. I've got 8 hydrogens. And I've got 2 oxygens. Now I'll do the same thing for the product side. 1 carbon, 2 hydrogens. And now, this is how Mrs. Fact suggests that you do it, and I agree. I think this is a really good way to do it. For my oxygens, I could put a 3, 2 here and 1 here. But rather than putting a 3, Mrs. Fact suggests that you do it this way. 2 plus 1. This shows that I still have 3 oxygens, but it's broken up between 2 compounds. So if I put a coefficient here, it'll only affect the 2. If I put a coefficient here, it'll only affect the 1. This is going to make our life a lot easier. So I've made my rep table. I know how many atoms of each element I have on both sides of the reaction. Now I need to add coefficients to balance this reaction. And this is actually the order that I'm going to do it in. And I suggest that you always do it in this order. Start with carbon, if you have carbon. If you see carbon in the reaction, it's a good place to start. Then hydrogen, and then any other element. Save oxygen for last. The oxygen is typically going to be the harder element to balance, so we can save that for last. So like I said, I'm going to start with my carbon. I see that I've got 3 carbons on the reactant side, so let's try to get to 3 carbons on the product side too. I'm going to make this a 3. Now if I made this a 3, that means I need to put a coefficient of 3 right there. Now I've got 3 times this 1 carbon is 3 carbons, and that balances with the carbons on the reactant side. But wait, I changed something else here too. Now I've got 3 times 2 is 6 oxygens right here. This is why I broke it up down here. Instead of only having 2, now I've got 6 for a total of 7 oxygens on the product side. But I'm still saving those for later. I'm not quite ready to finish that yet. Let's go to hydrogen next. 8 on the reactant side, 2 on the product side. I need to multiply it by 4. If I multiply it by 4, that'll get me to 8 hydrogens on both sides. But again, I changed something else here. This is no longer just 1 oxygen. Now I've got 4 times 1 is 4 oxygens. I'll make this a 4. Hopefully you can see that there. So 6 plus 4 is now 10 oxygens on the product side. To balance that out, I'll take a look at my oxygens on the reactant side. I can multiply this by 5 to get to 10. Now, all of my elements are balanced. 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, 10 oxygens, 6 here, 4 here, for a total of 10 oxygens. So if you're given an unbalanced reaction, I'll usually give you blanks if it's unbalanced. Your job is to make a rep table, reactants, elements, products. Get an initial count. That's like my numbers in blue here. That's the initial count. And then start changing those counts. Put in coefficients to change the number of atoms until it's equal on both sides. You might have to try this a few times. You might have to start over on some of the harder ones if it's still not balancing. But if you do this enough, eventually you will be able to balance these reactions. And I think if you use these rep tables, it'll help you even more. We're going to look at one more example, and I'm going to pick one that's on the homework, and then we're going to be done for this video lecture. All right, one more. All right, last little segment here. So we're gonna try one more problem like this as a class, working on balancing reactions. If you made it this far in the video, I guess that your reward is that this is one of the homework problems, and I'm gonna give you the answer to one of these homework problems. So looking at this reaction, I've got copper 2 sulfate reacting with elemental lithium. It's gonna make lithium sulfate and elemental copper. I've already gone ahead and made my rep table here. Let me grab some more colors. I still need to fill it in though. So let's start with E for elements. I need to see which elements I have, and I'll put them here in this column. I'm looking at 4 different elements in this reaction: copper, sulfur, oxygen, and lithium. But I'm going to show you a shortcut here. I'm going to list copper, and I'll list lithium. But instead of separating the sulfur and the oxygen, I'm going to notice that this is a polyatomic group, a polyatomic ion, sulfate. It shows up again over here, sulfate, SO4. So rather than splitting it up into sulfur and oxygen, I'm going to put the whole polyatomic down here. SO4, sulfate. And then I'll just count how many sulfates do I have. Looking at my reactant side, I've got 1 copper, 1 sulfate, 1 lithium, 1 of everything. And then looking at my product side, I've got 2 lithiums. This is only 1 sulfate. It would be in parentheses if there were more. There's only 1. And only 1 copper. So even though there's a lot of elements at play here, the actual balancing is not too bad. My copper is already balanced. I've got 1 on both sides. My sulfate is already balanced, 1 on both sides. The only thing that's unbalanced is the lithium. I've got 2 on the product side and only 1 on the reactant side. I need more lithium on my reactant side. So if I put a coefficient of 2 here, that only affects the lithium. And now I've got 2. 1 and 1, 2 and 2, 1 and 1. This is my balanced reaction. I really didn't have to do much this time. All I did was put that coefficient of a 2 in front of the lithium, and that was enough. So the new thing that we saw here, the thing that's sort of like a shortcut, polyatomic ions. If you see a polyatomic ion, you can treat it like an element when we're balancing. If it shows up on both sides of the reaction, we know that that sulfate's going to stick together, so we don't have to bother breaking it up into sulfur and oxygen. Alright, so there's one of the answers to the homework. That leaves you with 6 more problems to balance on your own. Again, this is one of those homeworks that if you are keeping up with everything, you can get it done in less than 10 minutes, easily. And then I will, of course, post the answers later in the week. I'm still doing office hours twice a day, as long as nothing has changed between now and tomorrow. So you can hop on office hours from 10 to 11 or from 3 to 4. You can come and go as you please. We will have a quiz over the reaction types and balancing reactions. That'll be on Thursday. I'll release the quiz, and I think I'm going to make that quiz due at the end of the day on Friday. So I'll give you kind of 2 days to get that quiz done. You only get 1 attempt though. Definitely email me if you have questions. Come to office hours if you have questions. You could hit up the chemistry chat room if you have questions, and people could help you there. use your resources, guys. Use the internet. Use each other. Use me for help too. So, I hope that you've been enjoying the e-learning so far. I'll see you tomorrow.